how to obtain the area of a rhombus or a parallelogram. And this is what we call a parallelogram, and this is what we call a rhombus. If you look at this figure, it is a special rectangle that has been drifted in such a way that the interior angles are not right angles. Number two, after the drift, the diagonals are not equal. If I measure this diagonal here, we have to measure the diagonal here and the diagonal here, looking at this is almost a complete ruler. But this one is less than that centimeters, meaning the diagonals are not equal. All sides, opposite sides are equal. At the same time, they are parallel. Opposite sides are equal and parallel. This one represents that this side is equal to this. This one is equal to this. But this is parallel to this. On a rhombus, the same case. This side and this side are equal and parallel. This side and this side are parallel and equal. But the special thing about a rhombus is a special square. All sides are equal. All sides are equal. And the only thing that is not equal in a rhombus are the diagonals. Because if I were to draw the diagonals here, that diagonal cannot be equal to this diagonal. But one special thing about the diagonals of a rhombus that is also found in a square is that the diagonals of a rhombus bisect at right angles. This is only the case. This case can only be seen in a rhombus and a square, where the diagonals bisect at right angles, not any other figure. Number two, so the things that a rhombus share with the square is that the diagonals bisect at right angles. The sides are equal, but and opposite sides are parallel. That those three elements are similar in a square. The only difference between a rhombus and a square is that, number one, the diagonals are not equal. In a square, the diagonals are equal. Number two, their difference is that these angles, the interior angles, are not right angles. For a square, all angles are right angles. The angles at the middle of the bisector and the angles at the corner here are all right angles. All interior angles in a square are right angles. Now, with that element, I'll play around with that element to get the area. But let us look at the area of a parallelogram first, and also the area of a rhombus. So to get the area, we simply take the line that has a perpendicular height. That line that has a perpendicular height is known as the base length. Then there is the height. So the moment I take this line, the base length, this one is known as the base. The line that has a right angle is known as the base length. The base length. Then I multiply by the height. Once you do that, you get the area of a parallelogram. If it is such a case, the right angle is here. So this is the line, but not outside the figure. Don't consider this part of the figure. This is the base length times the height. The area is the base length multiplied by the height. Let us look at an example now where we are asked to calculate the area of this parallelogram, and we are given these sides, the base and where you're given that this is 12 centimeters and this is 9 centimeters, maybe this is 13 centimeters. Looking at that figure, you realize that this is the base, this is the height, because there are the two lines, one line within the figure, not outside the figure, within the figure. The line within the figure that meets at a perpendicular line with the height is the base. So our base length is 12 centimeters multiplied by 9 centimeters. And therefore, the area is simply 108 centimeters squared, because all areas are found in square units, are found in square units. The next element, you can be given the same question. You can be given a similar question of the same kind, but this time round you are given that here is 10 centimeters, then you are given that this is 14 centimeters. This is 14 centimeters, and you are given that this is 6 centimeters or 3 centimeters. Let me use 3 centimeters. This is 3 centimeters. And you are expected to calculate the area. We need that the area is equivalent to the base length multiplied by the height. The base length multiplied by the height. Now the trick in this question is that 14 has gone outside the figure because it is inclusive of the imaginary line. We don't have any figure here. These are imaginary part of this diagram. So you cannot take 14. You cannot take 14 because 14 goes beyond. So from here to here is, you compare with the upper side because we said one property is that the sides are equal. So if this is 10, up to here is 10. Then the addition is here. So we are supposed to get the base length as, don't use 14 because it is outside the figure. It has included the imaginary line. So you shorten this and compare it to this. So your base length is 10 centimeters. Unfortunately, you cannot say this is the height because this angle is not a right angle. The height must be this one, and I don't have. Now that one becomes a technical area to handle now. What do? You simply break this longer side into 2, where you equate it from here to here as 10, but you need up to that level. I'm breaking down the 14, and then I break the other section here into 4. Because the balance is 4 centimeters. This part must be 4. And this part is 3 centimeters. No, I want to use this one as 5. This is 5. So this part is 5 centimeters. Now, here is a triangle that will help us get the height using the Pythagoras relationship that a squared, the two shorter sides are a and b, a squared and b squared should give me the c squared. So if I square this and square this, I should be in a position to get this. Now this time round I'm not looking for c, because c is the longer side that's available. I'm looking for the shorter side. So to look for, maybe I'll name this a, this b, this c. So to get maybe a squared, I'll need to take b to the other side. This was b plus b squared. I'll need to take this one to the other side. So a squared should be c squared minus a squared, or minus b squared. So it means I square this and square this and find the difference to get the square of this side. And what that means is I square 4, I get 5 squared, I start with the c, subtract 4 squared should give me the b squared, this one. Or should give me the a, I called it a. Should give me the a squared. So this is 25 minus 16, this one gives me 9. Therefore a squared is 9. What is a? A is the square root of that answer, and a is 3. Meaning that the height of this thing is 3 centimeters. 3 centimeters. Because one thing I'm insisting, you cannot work out the area without the base, that is not outside the figure, and without the height. Now you got the 10 after breaking 14 into 2. You got this 4 and this is 5. You worked out the Pythagoras relationship to get the height, which is 3. Now, is it possible to get the area? Yes. We simply say that the area of that figure is now the base length multiplied by the height. And I've said base should not be outside the figure, which is 10 centimeters. It is restricted up to this level, multiplied by the height that I obtained, and you get that the area of that figure is 30 centimeters squared, or 30 square centimeters. You have worked out the area of this figure without the height. Taking another question to do with the robust. Now let us look at the robust. The robust I'll erase this and draw the sketch of a robust, where you are told that this is a robust and you are told that you are not given any side, but you are given the diagonals. Let me draw a better sketch. You are given the diagonals of a robust. Here is the sketch of that robust. Here is the sketch of a robust. And instead of getting the base and the height, you are tricked and you are given the diagonals. You are given this diagonal as 12 centimeters or 24 centimeters, and you are given this diagonal as 10 centimeters. And this is given as 10 centimeters. 10 centimeters. You realize that this is a robust and you are expected to use the diagonals. To get the area of that robust, we simply say area of that robust is a half multiplied by diagonal 1 times diagonal 2. This is the area of getting that area. So you simply say that it is a half times 24 centimeters, diagonal 1, times 10 centimeters by 2, 1 by 2, 12. You get that the area of that figure is 120 centimeters squared. So the short formula is a half diagonal 1 times diagonal 2. And this formula is only applicable to a robust. Now I want to show you why. There is a longer way of doing it, where you are given, where you assume you split this robust into 2. That's exactly what I have done. And you form how many triangles? 2. So the first triangle here, this one becomes its base. I have split the robust into 2 so that I can confirm that formula. And what happens, this was diagonal 24 centimeters, so you get a triangle of this kind, this upper part. This part, the whole of this line was 24 centimeters. And this, from here to here was 10. Therefore, if it was 10 from here to here, it means this part was 5. 5. So it has a height of 5 centimeters. It was to get the area of this triangle, and then at this area of the other triangle, I'll get the area of that robust. So it is simply A equals a half times base times height, area of a triangle, which is a half times 24. Because we say these diagonals bisect at right angles. They bisect at right angles. So this is a right angle triangle. Times 5 by 2, 1 by 2, 12. You get that 12 times 5 is 60 centimeters squared. That is the area of the first triangle. That's the area of the first triangle. And remember that there is a similar triangle of the same kind, so you simply get the total area is 62 times, and you are getting to 120 centimeters squared. You get it to 120 centimeters squared. But instead of using this process, that's why I say you simply use the short formula. Area is a half diagonal 1 multiplied by diagonal 2. But this formula is also very important. You saw in the first question we got 120 as this. Why is this formula is important? Because at times we are also given such questions where you are given that this is a robust, this is a robust, another robust here, and you are expected to get the area with only one diagonal, given, like this, where you are given that this diagonal here, or let me give the longest diagonal. Where you are given such a diagonal, and then you are given one side of a triangle as 5 centimeters. 5 centimeters. Then you are told that this diagonal is 8 centimeters. 8 centimeters. And you are expected to get the area. Remember, you need to know that area of a robust is either base length times the height, or area of a robust is a half diagonal 1 multiplied by diagonal 2. Now, if I try any of these, none of them is, the closest is this one because I have one diagonal, but I need the other diagonal. So I need to use this formula, the second formula here. But how do I get the other diagonal? I simply drew it though I don't have it, and play around with this middle part, the right angled part of a robust. And from this, I can use this part of a triangle only, where I know clearly that from here to here is 8. Therefore, I erase this and divide it into 2. That from here to here is 4, so that this other part will be 4 to make 8. And from here I have a right angle triangle because I'm trying to play around with the property of a robust that diagonals bisect at right angles. So this is 4 centimeters from here to here. This is 5. This is the shorter side. So if I am able to get this side here from here to here, it will be equivalent from here to here. And I will get the diagonal 2. So how do I get this? I use the Pythagoras relationship. When I square this and this is the longer side. So 5 squared minus 4 squared should give me this. So I simply say a squared, c squared, the longer side, Pythagoras relationship, c squared equals, or minus, this side I'll call it a, b, c. So c squared minus the given a squared, I'll get b squared. So it is 5 squared minus 4 squared should give me b squared. This is 25 minus 16 once more, and I get b squared. 9 is b squared. B is the square root of 9, and therefore b is 3. B is 3. So b is from here to here. I already got this as 3 centimeters. 3 centimeters. With that now, I can work out the other part. If this is 3, this part is also 3. I have complete diagonals. 3 by 3, 4 by 4. So diagonal 1 is 8. Diagonal 2 is 6 centimeters. How do I get the area? Area of that robust will be a half diagonal 1 multiplied by diagonal 2. In my case here, I'll get a half times 8 times 6. You simply get 24 square centimeters. 24 square centimeters. I have an exercise for you to attempt.